All right. Hello, everyone. I hope you are okay. You have not seen me in a while, have you? I am Tracy Holmes. I'm a technical community advocate here at Isovalent, and welcome to eCHO, affectionately known, you know, as eCHO. It's, eBPF and Cilium. Anyway, we're here. Uh, I'm not Liz or Duffy today. So let's get started. This is episode 81. We're going to talk about open source XDP for Windows today. And let me get back on the right screen and we can get this party going. So normally I don't always do headlines when I'm on here. I have a couple. I'm not going to go in depth because of the subject matter today. We've got a lot to talk about, to be completely honest. So let's get started. Let's see what we have on the headlines. All right. So let me close this side. There we go. All right. So headlines wise, first and foremost, we want you all to go and register now for CiliumCon. This is the first time we're having CiliumCon, and we're exceptionally excited. So if you would go register, it will be 18th of April, and it's going to be in Amsterdam. It's a colo for KubeCon. All the registration details are here. We're past the CFP portion, but I'm very excited to see who all will be there and what talks we will have. The next thing I had is that eBPF actually has its own page on Wikipedia now. So if you haven't seen that, it's great. Like, it's a fully fledged page. You've got history, you've got milestones, adoption, who's using it, how they're using it a little bit, where the logo came from, everything. So please go take a look at that. And learn some new stuff. I like the fact that eBPF has a Wikipedia page. That's kind of cool to me. The next thing we have, a lot of the talks or a lot of the stuff that I tend to do are around security observability, because I'm kind of big on data and I'm kind of big on people not coming into my house that are not supposed to be there. And so one of the headlines that Bill sent out this week in Echo News, if you're not there, please subscribe, was this really nice write-up on what you need to know. And it wasn't horribly low level, but it gave you a nice little overview of what it is, what's monitoring, and why is not monitoring the exact same thing as observability. How does logging work? That kind of stuff. So, and I mean diagrams and everything, breakdowns, definitions, it's a really nice cumulative write-up. So go take a look at that. And last but not least, for some of you that this is your first day, you might want to know what in the heck exactly is Cilium. So my colleague Jeff decided to tell you all about that. WTF is Cilium. I love the header. I'm not going to lie. Go through here. It's a breakdown on what it is, how it started, who did what, why should you care? I think you'll like it. Jeff has a very nice sense of humor, and so you can find him all throughout this article. Okay, so those are the headlines, but that is not why you are here. So let me make sure I can tell you why you're here and I don't go too far off script. All right, so who I have with me today is, first let me go back before I bring him on screen. When I first started, I did a live stream with Liz, and one of the topics for one of the headlines was open source XDP for Windows. Liz and a few other people will jokingly say that the only thing they know about Windows is that it's an operating system. So I feel like I'm one of the few people out there that try to give Windows, a go, especially since you have WSL and that kind of stuff now. So I finally was able to get in contact with the author of that particular blog post, and his name is Nick Banks. And Nick is the lead of networking transports team at Microsoft. So, Nick, feel free to introduce yourself.
All right. Thanks a lot, Tracy. Thanks for having me. Excited to be here and tell you all about XDP. As you already said, I'm lead of the networking transport team here at Microsoft. The platform team, we do stuff for Windows, Xbox, Azure, kind of
Oh,
anything that uses the network at Microsoft goes through our team. Pretty kind of fundamental team. So we get a lot of stuff. One of the exciting things we work on is XDP. So I've been here a little more than 12 years. I
okay.
started in Wi-Fi, actually on Windows Phone, and
Oh, wow.
merged with Windows, and then Phone went away. Eventually, I moved a little bit up the stack into the transports team, took ownership of the Quick protocol, built that up, and eventually transitioned to the lead and kind of manage the team. And XDP is one of the things we get to work on. So
I was one of the people that actually liked the Windows Phone. I hate that that didn't work out. It was a way better implementation of that tile aspect than Windows 8.
yeah,
I'll
yeah.
tell
I
you that.
mean, it's one of those things that it's hard to break into a market. Fundamentally, came down like the App Store. There were
Yeah.
lots of apps and Android and iPhone, and it's just really hard to break into that. And that's it happens sometimes, but yeah.
And and then before we go into the questions, I never even thought about how your team would actually affect something like Xbox.
Hmm.
Like,
Yeah.
how does that even?
I mean, if you think about it, our team owns from the IP layer of the
Mhm.
networking stack up to the sockets API. It's the same stack that runs in Azure, on Xbox, on Windows, server and client. So it's all the same stuff. So we work with just about every team at Microsoft. I mean, nowadays, who makes a product that doesn't use the internet, right?
That's true. That's
So yeah, it's really exciting team to be on because we get to work with so many other folks out there, internally and externally. A lot more of our stuff going open source. It gives us a chance to work and talk with folks like you that are interested in using some of our stuff on uh, even different platforms. This one obviously is for Windows, but we're trying to kind of standardize that. So kind of play nice with the rest of the community.
nice. All right. So another one of those. If this is your first time here, what in the heck is XDP? Like, why
Yeah.
should I even be excited about it?
So yeah, XDP stands for Accelerated Data Path. Super generic name. I mean, for networking, folks only come to you if there's either a problem or they want to make things faster.
Sure.
That's really all they care about networking. It's a given that it should work. You just want it to work even faster. So as the name implies, that's what XDP's job is. Right? The goal is to accelerate it to make it faster. Um, on the Windows side, over the years we've spent as much time as we can improving the existing networking stack, and it's kind of come to a head where you can't really make it much faster. And Windows has a lot of legacy. That's where a lot of the money comes from. I mean, somebody's got a business that and they wrote something a decade or two ago, and it needs to still work, and we
Sure.
can't break that. So that kind of puts us in a bind where like we want to make things better, but we have to be able to support those other things. So ultimately, the existing stack has kind of reached a point of you can't make it any better. So that's where XDP comes in.
Mm-hmm.
It's all about providing kind of a parallel channel, bypassing the existing networking stack to say, hey, here for those special cases, which is most server scenarios, for example,
Mm-hmm.
that don't need all that legacy stuff. You're making a new system, hooking into something like eBPF. You want it as fast as possible. That's where XDP comes in.
All right. So, let's see. You already answered the first question. That was nice. Thank you. We're going to talk about the problem that it tries to solve, and you just talked about what that problem was.
Sure.
Um, because you know what? You mentioned a diagram.
Yeah,
Let's show that
let's go to
diagram.
that.
All right, let me do that.
The
Let's see.
diagram kind of helps. I imagine a lot of people aren't familiar with XDP, but let alone the Windows networking stack, right? There's a lot of complexity.
There it goes. All right.
Put together a simplified diagram here. You got this dotted line up here. Everything above the dotted line is your user mode, your application. Everything below it is in the kernel. So there's a bunch of big blocks here. Fundamentally, you start down with the networking hardware, and it goes up the stack. Everything in blue is what we kind of consider legacy, the old existing networking stack that everything goes through. The green stuff is where we're starting to invest and improve things. So as you can see, XDP plugs itself in down here at the bottom, as close to the networking hardware, sits on right on top of the driver, to intercept the data path as soon as possible. Like I said, we've done everything we can to make the TCP/IP, the socket layer, all these things as optimal as possible. We're at the point where the only way to make things fast is you have to skip it. To skip it, you have to plug yourself in underneath it and just bypass it altogether. So that's what XDP does. Indus is the networking driver framework, and it uses Indus to plug in as a filter driver, and filters packets. Filters can add, remove, modify packets, so it leverages that behavior, plugs into the very bottom, and essentially everything builds on top of that. So that's where you can see you're able to skip a bulk of the networking stack by going through this model.
That's cool. Also, I really need to get better at diagrams. Oh, also, I forgot to tell everyone, anybody that's on stream right now, if you have any questions, I should have done that. Hi, everybody. Again, if you have any questions, make sure to add them into the comments, and I will make sure that we address any questions you have.
Of course.
All right. Let's see. What else do we have? All right. So I'm not going to ask the forwarder question yet. I'm going to go and talk about how it works in relation. So how does XDP work in relation to apps? You mentioned MissQuick integration, and also compare performance data. What exactly is MissQuick?
Yeah, MSQuick is the Microsoft Quick stack. So it's also open source. It is mainly used as a user mode networking stack. So Quick as a protocol builds off of UDP and provides all the kind of features you get normally from a TCP, like a reliable stream, but a lot more. And it brings in a lot of parallel streams. It has reliable and unreliable delivery. Bottom line, it's kind of like the next transport for the internet. HTTP3 is built on top of it. DNS is going to it. Lots of protocols are all moving to Quick because the industry kind of got together and built that. I took 30 years of experience and said, hey, how do we fix the networking protocols? And they came up with Quick. So much of the industry is moving there. So for us, though, our team owns Quick and XDP, and they're like, how can we put these together and make Quick MSQuick the fastest possible kind of application layer solution, and make it dead simple for the application layers to use. So MSQuick has an API on top. Apps call it, and I do whatever they want, whether it's a custom protocol or an HTTP stack. So that API is what the applications talk to. Underneath, on the bottom of MSQuick, is where we abstract things like socket communication. So by default, normal MSQuick just sits on top of a UDP socket, sends and receives UDP packets, and does everything that the Quick protocol needs to do. Now, XDP comes into the picture here. It provides that super fast data path to like talking directly to the hardware almost, but it comes at a cost. The interface that XDP provides to the application layers is not UDP packets, it's Ethernet frames. So if you think about it from like the perspective of building a protocol, normally everything's built in layers, right? That's kind of fundamentals of networking. Every component handles its layer. The next component sits on top of it, does its layer, and you've got all these different layers.
Right.
that provides really nice abstraction, but ultimately can add a lot of extra latency and performance hits and stuff. So you've got this trade-off. And lately, a lot of the networking world has been going towards the smush everything into one. It's really complicated, but try to hide that complexity so the apps that call you don't have to worry about it. You get that one complicated thing working really well, really fast, and then overall that gives you the best possible solution. So that's what we have here. So XDP provides the ability to send and receive Ethernet frames. On top of that, you have IP, and then you have UDP, and then you have QUIC. So the integration with QUIC requires kind of all those layers to be built into that bottom of the stack. But the real win here is ultimately the application layer doesn't see any of that. So the application layer sits on top of the MS-QUIC API. As far as I know, they're like, hey, give me a stream, send some data on the stream, receive some data on the stream. They're completely, I'm oblivious to that, and rightfully so. That layer is really complicated to get right. My team owns the networking stack, and it takes us months to figure out how to get that stuff just right. How can we expect somebody who's writing an app, and even if they are knowledgeable about networking, usually networking isn't their only job. They're like, okay, I have to work on the networking part. I'm the networking person for my team, but that's just one little part I do. I do it for a couple days, get it stuff working, and then I go back to my normal job, usually some business logic or something. So that's where like our entire focus is to making sure that is super efficient and clean and easy to use. So that's where like MS-QUIC comes in here, that it provides kind of an easy button on top of XDP. If you were going to take XDP as is, and you're like, hey, look, I want to write an application on top, it's going to be a challenge if you want to do something that like does higher layer protocols. Now, if you're going to write, say, a load balancer or something, where you're dealing in low level packets, like I send and receive IP packets, I do very little processing, I don't really care about the contents. Using plain XDP is the way to go. It's going to be much faster than if you try to hook into the existing socket stack. A lot of it you can't even accomplish with normal sockets because there's so many layers in between you that do extra stuff there, that if you write an app, you just don't see that. You're not plugged into the networking stack. XDP gives you that kind of side channel to hook into it. So with MS-QUIC, yeah, the goal is don't change the top level API, just make it work and make it really fast. So want to show, I'm just a quick, I don't want to go into too many details here. Like one example diagram.
Okay, yeah. Is it the request latency? Yeah, I see it.
Yeah, okay. So let me simplify this real quick, and then I can add in more. So these two graphs right here, the blue line is just a normal window, like normal socket-based MS-QUIC. The gray line here is over XDP. So this is just a lab setup we have that does kind of a RPC style, send a request, get a response, do it a million times, graph the percentiles, like what are the latencies, how good does it look? And you can see the differences here. So everyone kind of cares about different percentiles, but in every single percentile, whether you're talking about 50th percentile or 5 nines, your latency with XDP is much better. Now, to kind of put that in perspective, this green line is what the latency looks like if you don't actually write an application. If you were to write a driver, meaning going back to if you were to write a driver that sits in the networking stack down here, it shows you XDP is that much faster even than that, because it bypasses all the networking stack, this bit. So your driver, if you're writing a driver on top of the existing networking stack, you still kind of fit somewhere in here. So you still have all this to go through. And that's where kind of all the legacy stuff is. So this means a user mode application using XDP can blow out of the water performance even compared to a kernel mode driver. And then comparing this to Linux, this is a Linux socket based. So this is where Linux sockets, and also to be fair, this is just the latest commit. So every commit of our pipeline looks a little bit different, but I mean, this is essentially raw data. Yesterday or today, some commit that went through our pipeline. But this is giving us kind of the ability to do things with user mode networking stacks that were very difficult, if not impossible, before. To have really low latency, kind of distributed data center communication that almost, we're still working on it, but can start approaching things like RDMA capabilities. And with this, you bring a lot more. QUIC is a full transport protocol that works over the internet and everything like that. So yeah, and so that's just one aspect. So like XDP, as you saw at the diagram, it can plug up to the application layer, right, but it also can hook over to things like eBPF.
Speaking of which, now we can go to the demo. Yeah, so let's talk about XDP in relation to eBPF.
Yeah.
And and viewers of this channel have heard about eBPF their entire channel lives. Like, so I feel like they'll be really interested in the demo that you're gonna show.
Yeah. So as you all know, eBPF is a pretty general purpose kind of functionality. You write programs and it runs it in the kernel for you. One of the big parts of that is networking. And again, coming back to networking, people only want networking to be fast.
Yes.
And if you're running in the kernel, and you're trying to make these super efficient programs that do things, all sorts of things. Load balancing, redirecting, any kind of inspection. The pretty much limitless possible solutions with eBPF.
Mm-hmm.
We need the networking part to be fast. So, and then that's where XDP comes in again. So XDP, I know we're saying, hey, look, eBPF is new. It doesn't need all that legacy stuff that Windows has built up over the last 3 decades or whatever.
Mm-hmm.
Let's hook it up into this new technology that bypasses everything, that's already proven super fast, and let's make eBPF super fast. So you can build an eBPF program, push it down, and you get the best possible performance.
Right.
What else? So how about we do the little demo real quick? It's not super exciting, but I feel like networking demos never are super exciting.
I mean,
so to set the stage here, in this demo, we've got a setup. It's on real hardware, but it's processing essentially fake traffic. You've got fake traffic coming in as fast as the CPUs can handle it, which I think is something like 300 gigabit per second. So you've got this traffic coming in at 300 gigabits. Right now, the default state is it's not going anywhere. You don't have anything running, anything receiving it, anything processing it. So it's just getting dropped on the floor almost immediately. Okay. So you've got tons of traffic. So you can see over here in Task Manager on the Ethernet device, it's got a receive of 300 gigabits. The cores are completely maxed out. All it's doing is receiving packets and dropping them. Nothing particularly exciting.
Right.
But the goal here is how can you take eBPF and XDP and kind of do one of the common scenarios is I want to load balance or redirect this traffic. So you have traffic come in, you decide where it needs to go, you send it back out. So you imagine these packets, eBPF program runs, it has to receive the packet, decide what to do with it, and then send it back out. So first we wanted to show, like with the legacy networking stack, what that does.
All right.
So my coworker here built up this demo, and you just have, this shows you kind of starting eBPF and running it. So we pause it here. You see, he loaded an eBPF program that used the legacy networking stack. And you can see the second you enable eBPF with that legacy networking stack, the throughput, receive and send, drops from 300 gigabit down to 12, 15. It fluctuates because now you've got the entire networking stack going up the receive path. The eBPF program runs, then it has to go all the way back down the send path. So there's a lot of code it has to transfer through there. And that's what that means. With these 4 cores, that's how much it can process.
Okay.
So let it go through here. I essentially stops the legacy program, starts XDP, and then runs it with XDP. And then you can see what the difference is. So you can see right now, XDP is running, and your rate dropped from about 300 to 297, and it's being able to forward that right back out. So that gives you an idea of the performance difference here for this kind of scenario. And this is kind of the best case possible scenario because you're not doing a lot with it. The eBPF program is just, okay, I received this packet, I need to send it back out. I'm either a load balancer or some kind of in-cap, decap, probably like forwarder. I'm very minimal processing, but it shows you kind of what the difference of legacy networking stack versus the XDP stack that's able to bypass it. Night and day. I think it's something like a 20x difference for this scenario. It's just huge. And one thing, this is still really fresh work. I think they got this working last week, kind of thing. So this stuff is still work in progress. It's only going to get better. Performance going to improve further. Capability is going to improve further. So this is not something that okay, take this and ship it right now. But as you can see, it's come a long way. eBPF, XDP, all working. Pretty trivial just to load this program and you're off.
For those of you watching, in the show notes, I have a link to the demo as well as the GitHub repos for XDP for Windows, which I'm going to ask you about eBPF for Windows. But as a general question, how do I want to word this? Why is it so important that it's working for Windows now? Because I don't think people may understand what exactly that means. They just hear it, and of course everybody just automatically associates it with Linux, and of course you've got WSL and all that integration and stuff now on Windows. But what does that actually mean? I guess you could say for the future, or just in general for it being on something that's been historically closed.
Definitely. So obviously Linux spearheaded the way here, built their technologies. XDP and eBPF are going slightly different routes, at least for the time being, though that it may change. So eBPF is very much trying to get a single, somewhat converged, or at least shared code model working for Windows and for Linux. That is more feasible for eBPF because it is a general purpose execution. I need to generally run programs, and then I have hooks for different things like networking. XDP, though, it's all about the hook. How do you hook into that particular platform? So that's why, while the names are the same and the goals and general functionality are the same, they're still very much separate because it's all about how do you hook into that platform. Hooking into Windows is extremely different from hooking into Linux. So 99% of the code is just going to be different fundamentally. But really, as far as fundamentally, why is this important? It's important for a number of ways. One, a lot of people still use Windows, and they want to get the same kind of benefits that folks that are on Linux have. And with the operating systems, there's always pros and cons. You get different things. But this is one of those things we want to be able to close the gap, so we have it on both. And while at the same time we're trying to close the gap and have the same stuff as Linux, we're also targeting different things like the MS Quick XDP scenario. And it's right now we only have integration with Windows XDP. Eventually, because MSQuick is cross-platform, it runs on Windows, Linux, Mac,
Okay.
Android, iPhone, pretty much everything. So eventually we'd want to have the same kind of support. But since our team is obviously specialized in the Windows side of things, that's where we tend to go first. And it's still a new technology. It's a lot easier for us to learn and figure out how all these pieces go together when we can talk to the person making the other part in the next office, kind of thing. But like I said at the beginning, ultimately the goal here is to make things faster. And it doesn't matter what operating system you're running, what application layer or protocol, everybody wants that. So that's why we put a lot of time and effort into building up these products to make these things faster. eBPF brings a little bit more because it's not just about the speed, it's about simplicity and safety to be able to like simply write a program and safely run it in the kernel on your behalf. If you could do the same thing if you wanted to write a driver yourself, but it's going to take you at least 10 times as long, and you probably have at least 10 times as many bugs.
Yep.
And nobody, even us who own stuff in the kernel, don't like working.
Nobody wants to have to
It,
deal with
so
it, right? Oh man. Okay. So I think we're actually gonna wrap. I'm not gonna. So for all of you that thought this was gonna be an hour, I was shooting for 30 minutes, and I'm gonna tell you why. One, the fact that we could even talk about this happening on Windows was enough for me, like just to give you all general information, because I know not everybody goes and reads the blog post, not everybody goes and looks at the headline, but like at the headlines. But like I feel like it was important to kind of like put it out there so people know like Windows is not being forgotten. You know what I mean? And that blog post that you shared had like it was succinct, but it had like really good information. And so, are you gonna do a write up on the eBPF for Windows one too, or did somebody already do that?
I think there might be one or two out there. I can go look for you and see if I can find a link for you.
Okay, yeah, no, we can do that like outside of this. I don't actually have any questions or anything in the comments, and so what I will say is I do have a link to Nick's Twitter handle in the headline. So if you have any questions around this, I already know my colleague is probably gonna ping you and go, so hey, I wasn't able to make it, but let's talk. So that's going to be a thing. And for those of you that are kind of like me, where just like you know enough about networking to be dangerous, that same colleague should have some stuff coming out about networking and eBPF soon. So be on the lookout for that. And you know what? I am happy with how this went. And we made it past 30 minutes, so I'm not going to complain. Did you have anything else that you wanted to say?
No, I think that's kind of the meat of it. I mean, we could get into technical details and talk for hours, but yeah, I don't think anyone wants that.
Yeah, there's that. That was the other thing I didn't say. There's that line between touching the high level eBPF and then waking up tomorrow realizing that you're still talking about it in your sleep. And we don't want that side of it. We're gonna stay on this side of it. All right. So what we will do now, and if you stay on after we do the whole freeze frame wave thing, that's going to be it. Thank you all for joining us today. You can also add comments in the YouTube comment section for this video whenever it is published. And we will see you all next time. Bye.
Thank you.